So as we move into the surface area of 3D shapes, remember we just went over different types of shapes. So notice the shapes take on this 3D dimension. So they have length, they have width, and they have depth or height. So basically they can hold stuff. Now getting into surface area is a measurement that tells you how much total space the outside can cover. How much total space it takes to cover the outside of a 3D shape. So again, surface area is going to be the total area of all the outer surfaces, which we also call faces. Because you remember those surfaces we defined as faces. So they're going to take on these different shapes as well. So again, as we were talking about, to find surface area, we're talking about like painting a campus. How much paint does it take to paint on a canvas or a wall, if you will, if you're painting a house? Or if you're using wrapping paper, how much paper does it take to cover an object? Those are examples of surface area. So again, the amount of paper needed is described as the surface area. Now, when it comes to shapes, we can use formulas to determine how much surface area is on a shape, and we can kind of go from there. So a cube has six square faces. So notice that the surface area is going to equal the area of all six squares added together. So see if I can get this here to open up for us. So if I want to find the surface area of a cube, notice how, again, I can close it. Let's see, this thing to close here. This is kind of not. So there's our cube. Notice that all the surfaces are there, but notice how like some of these are not as easy to see. So if I unfold this, you can see the surfaces. So notice how each surface is actually the same amount of space, the same amount of surface space. So notice how since each space is a square, we can use the formula of a square. A equals side squared, and that would determine the area of this of each surface, if you will, each face. So if I say this is S, then this has to also be S. So if I multiply S times S, that gives me the area of the surface. But since there's six of those, the surface area is going to be 6 times S squared, since we have six faces. So we have that going on here on a cube, if you will. So see how unfolding this thing can kind of help you see the different surfaces, and they're all the same amount of area. So to find the area of a cube, the surface area of a cube, our formula is going to be the surface area is going to equal 6s squared, since s squared represents the area of one face, but you have to add all of them together. So since there's six of them, we can just simply say 6 times s squared, and that will do all that math for us. So the surface area of a rectangular prism, a little bit different. So rectangular prism is not all the sides are the same. We're not going to do other prisms. We're just going to focus on it, the rectangular prism. Let's see here. Okay. So calculating the surface area of prisms, again, we use these nets. These nets are basically unfolding of the shape. So here we have this rectangular prism, or we would call it a box, if you will. Notice how I can unfold the box and it creates, again, six faces. But notice that these faces all have, so let me see here, click on all sections of the net. So if I click on this section here, notice this section here and this section here kind of are like the front and back. So notice how they have the same dimensions. The width times the height would represent their surface areas. Notice that B and D would represent the left side and the right side of the box. So if I click on B and D, notice how they're the same dimensions because that's the left side and right side. So that's going to be the length times this height. Again, because this 4 is going to be the same thing as this as well if we put it back together. Okay. And then if you click on, notice how C is the bottom and D is the top, or F is the top. So notice how their dimensions are the same. So we would have that. So notice how we have really A and E are the same, B and D are the same, and C and F are the same. So if I replace the variables, so if I just click on a side here, I believe, replace the variables, we'll just click on the segments. So there's the 4s, so that's the heights. If I click on that, that's going to be the lengths. And if I click on the widths, substitute those in. If I calculate that, notice how their A and E is going to give me the same surface areas. There's the 12s, so it's two 12s. There's another two 12s, and then there's like two 9s. So we have two 12s, two 12s, and two 9s. So we have 66 square units. So notice how to find the surface area, since two of the surfaces are the same, we can kind of take that in consideration and we don't have to do six surfaces. We can only have to do three surfaces, and its opposite surface would, or its opposite face would be the same amount of area. So when it comes to prisms, our formula is going to be for the surface area of a prism. So it's going to be a box. You're going to have like length times width times height. So we have to have two lengths and widths. So 2LW. We have to have two lengths and heights. So we have to have two lengths and heights. And we also have to have two widths and heights. So we have those different combinations, two widths and heights. So we have really recognized, like, we have like the front and the back. And then we have like the left side and the right side. Oops, just say our side. Not even close, was I? Try it again. Trying to abbreviate. So left side and the right side are going to be the same. And then you have like the top and the bottom. So top and bottom. So as long as you can figure out what dimensions represent the front, those same dimensions are going to represent the back. Whatever dimensions represent the left are going to be the same dimensions that represent the right. Whatever dimensions represent the top will represent the bottom. So you can use that as a format to do that. So let's see if we can do another example back here of folding the cube. Let's see here. Not the cube, I'm sorry. That's all the same. Doing the prism. So again, notice how, depending on how your orientation is, if I want to find the surface area of this object, notice how if I call this the front, it's going to be 3 by 4. But notice how that's also going to be the back. So the surface area is going to be 3 times 4, but we have two of those. So 2 times 3 times 4. And then if we have the right side and left side, notice how they're going to be length by height. That's also 3 by 4, but we're going to have two of those. So 2 times also again 3 by 4. And then we're going to add to that, notice how we have the bottom and the top, but notice how they're 3 by 3. So we're going to have two of those. So 2 times 3 by 3. And again, we already did that math. We would have 24 plus 24 plus 18. So it's going to be 48 plus 18, which gave us that 66. And remember, since it's area, this would be square units. So if I call these in terms of feet, all these have to be in the same unit if they're all in feet, then we would say this, the surface area is 66 square feet. So we put a little FT with the power 2, since we're talking area, that'd be square feet. Okay, so let's stop there and then we'll move into our next shapes.